Welcome to the Thane Heins Potential Difference YouTube channel. In this video demonstration, we're going to be demonstrating the ReGen-X Motor innovation and focusing on electric vehicle applications. So we're going to be demonstrating the ReGen-X motor and the ReGen-X generator and outlining what kind of performance can be achieved in an electric vehicle. So many electric vehicles today have more than one electric motor. And what we're demonstrating here is we have a universal motor that is driving a generator, or a direct current machine. This can operate as a motor or a generator. And so we're using our motor to drive our other motor. Now, if somebody came to you and they said, I want you to use this motor to increase the speed of this motor by 295 RPM, but you're not allowed to put any electrical input power into this motor, you would probably think that that person is crazy. And that's basically what we're going to show you in this demonstration. Is we have our EV traction motor that's driving the ReGen-X generator, and the ReGen-X generator, the ReGen-X motor, when it goes into motor mode from a state of rotational equilibrium where we're at right now, when the ReGen-X motor is employed, it has the capacity to accelerate the entire system without requiring any electric input power. And the ReGen-X generator, when it's connected to a battery, it has the capacity to recharge the battery and while also accelerating the EV's original traction motor. So if I want to increase the speed of this system, if I want to increase the speed of my dual motor system, I have to increase the input power to one or both of the motors. And if I want to generate electric output power from my generator, I need to supply additional mechanical input power in the drive shaft above what is established at rotational equilibrium. Because at rotational equilibrium, or steady state speed, the power in the drive shaft is 0 watts. So what we're going to do is we're going to bring the ReGen-X motor up to speed, and we are going to demonstrate system acceleration, 295 RPM of acceleration with a motor that requires 0 watts of electrical input. And what you're going to see is the primary motor, or the prime mover, will incur a reduction in input power by 41%. So we're increasing the kinetic energy of our system by about 20%. We're reducing the power consumption in our motor. Again, in an electric vehicle, if you have 2 electric motors, you use the 2 electric motors to bring you up to speed, and then you only need 1 to maintain speed. In the ReGen-X motor EV application, you can use one of those motors as a motor that increases the speed of the EV but isn't consuming power from the battery, while simultaneously reducing the power consumption from the EV's original traction motor. And if you want to go into electric vehicle regenerative acceleration, then you connect the motor, the ReGen-X motor, to the battery, and the generator accelerates the system as well. Approximately, it's going to be about 44 RPM, and the input power to the original traction motor is going to go down by about 7%, and the generator in this demonstration will generate about 113.5 watts to the battery, and you'll see the battery recharging. So I'll fire up the system. I'll show the ReGen-X motor operation first, and then I'll show the ReGen-X generator operation, and then we'll do a summary of the data. 285 RPM. With 113 watts going and recharging the battery. Cruising speed. At 3,457 RPM. Using the ReGen-X motor to accelerate the system while simultaneously reducing the power consumption of the original EV traction motor. So the data summary is our idle speed for the ReGen-X motor. Item number 1 was about 3,276 RPM. Obviously it was different in this demo. This is previous data. And the rotational kinetic energy at that speed is 14,000 joules. We increased the kinetic energy of the system to 16, almost 17,000 joules. The ReGen-X motor consumption is 0 watts. The total RPM increase is about 295 RPM, a 2,700 joule increase in rotational kinetic energy. The original EV traction motor's input went down by 41%, and the efficiency of operation of the ReGen-X motor, increasing the speed of the system with no electrical input power, is infinite percent. Then we demonstrated the ReGen-X generator. Our idle speed was around 3,278 RPM. We generated about 113 watts to the battery. We increased the speed of our system by 44 RPM. The prime mover input power did not increase. In fact, it went down by about 7%. And the mechanical input power to the generator when we were delivering 113 watts was less than what was required at idle, which means it was less than 0 watts. So the efficiency of the ReGen-X generator in regenerative acceleration mode is also infinite. Thank you for taking the time to watch this video. Cheers.